Hello everyone, Madam Tan here again. Hello, let us continue with tutorial question. If you look at here, got a graph question, page 19, number 8. Okay, so let's look at this graph. And first of all, from the graph, you should know how to interpret the graph. Means you have to extract what is info given. If you look at here, y-axis is actually, if you look at here, the state is actually velocity, and on our x-axis of our graph is time. If you look at here, what they want in the question is actually part A. They ask about describe the motion for the object from where to where. If you look at here, so please use your highlight pen to highlight BC part. Okay, we have BC part here. So this one is our BC part. They ask us to, okay, kalau tengok kat sini, kalau dalam bahasa describe maksudnya you kena menerangkan dengan lebih lanjut lah. Tentang apa? Tentang pergerakan dari mana ke mana, B ke C. Okay? Jadi kalau kita tengok dekat sini, okay, dari B ke C, kalau kita tengok benda yang paling asas dulu, iaitu terus dapatkan nilai V dari sini, kita dapati apa? Nilai 20 meter per second. Okay? Jadi didapati dekat sini ada satu nilai yang agak berguna. Okay, which is very useful, 20 meter per second. So what is this actually? Jadi kita baca nilai terus dan bergerakan. Jadi nilai iaitu kuantiti pada y-axis ini apa ni? Is actually, this one is actually velocity, right? Velocity, And then what do they want? Apa yang mereka mahu adalah ini. Dari pergerakan B ke C sahaja. Sahaja, dengar dekat sini, sahaja. Okay. Jadi kalau kita tengok bahagian ini je, okay, what can you see actually? Is actually along the motion here, or along the journey from B to C. What can you observe is actually constant. It's actually maintain same value of velocity, iaitu along the journey here is maintain the same value 20 meter per second. So what is this called? Ingat, kalau dia mengekalkan nilai magnitude yang sama, kita panggil apa? Constant. Ada satu keyword constant dekat sini lah. So means that this object actually, okay, moving. Okay, sebenarnya dia bergerak kan? Sebab ada nilai h laju. Kalau objek kita ada nilai h laju, maksudnya objek kita sedang bergerak. So we have the object is actually moving, or object moves with constant velocity, which is 20 per second. Okay, and remember, kalau constant velocity, acceleration dia macam mana? Yeah, the answer is 0. Okay, so means that the object actually undergo what we call zero acceleration. So this one actually you should know already. Okay, kalau kita ada idea kenapa buat zero acceleration, okay, nanti tak apa. Nanti kalau yang tak faham ini, bahagian ni, kamu boleh tanya madam secara face to face. Okay, jadi ini untuk bahagian A, bahagian A. But how about bahagian B? Okay, so let's look at part B. Part B, what they want is actually we have to calculate acceleration. Kemudian kalau saya tengok yang seterusnya, if I visualize the problem, apa yang dia mau lagi? Untuk Roman 2, they ask about what is the value for deceleration and, okay, and third one, they ask us to find the total distance traveled. Okay, so first of all we look at this part. Okay, what do they want? Dia nak kita cari nilai pecutan dekat sini. So we look at here. Okay, we look back to the graph again. Part BC, as I say, and zero acceleration, right? Okay, jadi untuk kita kira, bahagian graph mana yang undergo acceleration, you akan dapati, I will say, it's actually bahagian graph di mana bahagian inilah acceleration, maksudnya nilai V kita mesti semakin bertambah lah, okay? Jadi untuk kita kira Roman 1, I should consider part A only, part A to B only, sebab bahagian graph ini di mana memang dia undergo acceleration. Okay, acceleration ni. Jadi untuk kira A, apa yang kita buat? Kalau you tak ada idea, tak apa. Sebelum ini, Madam pernah ajar untuk graph VT. Ni tengok, ini graph velocity versus time kan. Macam mana kita kira gradient kan? Macam mana kita kira acceleration from VT graph, remember? Find the gradient for the graph lah. Find the gradient for the graph. So you look at here. What is the gradient for the graph in this case? Kalau you tak ada idea, tak apa. Okay, we do slowly. Where, in order to find the gradient for this part, okay, you just consider this one as your coordinate. This one another coordinate. This coordinate, let's say I just label x1, y1. Okay. And then another coordinate, I just label this one as x2, y2, for example. So in order to find gradient, remember in the lab, we discussed before, in order to find gradient, we have an equation for the gradient, which is like this. Hopefully you can recall back this important equation for the gradient. Lepas tu, kita hanya ganti je. We just ganti je apa koordinat dekat sini ya. Contoh koordinat dekat sini berapa? Kalau you baca koordinat A, koordinat dia adalah dia dekat asalan kan? Dia dekat ni. So this one is actually 0, 0. But how about this? This one will be 4, 20, right? So this one will be 4, 20 lah the coordinate dia. So what you're going to substitute there? Lepas tulis formula, second one do the substitution. What is your y2? 20 minus y1 is actually 0. Bahagi dengan apa? 4 minus 0. So I have 5 here. And don't forget the unit. Okay. If you have no idea about the unit, what can you do? Bahagian atas ini adalah sebenarnya H laju kan. H laju. Kalau tengok sini, kalau untuk kita kira gradient kan. Untuk kita kira gradient, kita akan guna delta y bahagi delta x kan. Delta y adalah y, beza nilai y, unit dia berapa? Ini kan, meter per second yang bahagi ini ya. Okay, so we are going to use meter per second. We are going to use meter per second yang bahagi second. Jadi meter per second bahagi second, what do you get? You get this. Okay, so this one is the acceleration for part AB. Alright, so hopefully you can follow. Then quickly we move to the Roman 2, how you're going to find deceleration. Okay, so in this graph, there are 3 different kind of motion I can say. This one acceleration, this one constant velocity, and here we have decelerate lah. Kenapa kita kenali ni sebagai decelerate? As I give you the info before, where decelerate usually in your dalam peringkat kamu decelerate ini kita tengok kalau velocity berkurang, contohnya dekat sini velocity dari 20 berturun sampai kosong kan. Kenapa kosong? Kita baca paksi y sebab paksi y kita ada H laju. Jadi dari 20 kalau berkurang sampai lah kosong, laju berkurang itu kita kenali sebagai deceleration biasanya. Okay. So if you look at here how you're going to find the value of A here. Okay, so same thing. It's actually equals to gradient for your graph lah. Gradient. So how you're going to find gradient for part CD? Remember part CD in this case, how you're going to find gradient? Same thing. Use the equation for the gradient, which is this. Okay. Equation for the gradient. We have this. It's look messy, madam. Rewrite again. So for part B, what do we have? This one is actually deceleration. Okay. So our A is actually equals to the formula for a gradient is actually this one. So here, it's actually we only concerned about this part, C to D. And what is x1, y1, x2, y2? That's important we label this point, these 2 points. Okay. So point C, kalau saya label, okay, contohnya ini kita label sebagai x1, y1. Okay. Nombor ini kena konsisten bagi point yang sama. Kalau ada point yang sama, kalau ini saya tulis 1, ini pun tulis 1. Jadi koordinat dia macam mana kita baca? Baca X dulu kan, 10, 20. Ini koordinat dia. Ini pula, kalau ini X1, Y1, ini pula X2, Y2 lah. Jadi koordinat ini macam mana baca? Baca paksi X dulu kan, iaitu 12, kosong kan. 12, kosong. Dan baru kamu ganti ya. Okay, baru kamu ganti ya. So here, what do I have is actually Y2 saya kosong yang tolak 20 bahagi dengan 12 tolak 10. So what do I have? I have this and then negative 10 meter per second square. Alright, jadi ini nilai A kita. Ini nilai A kita. Dan that's it. Don't forget the unit for acceleration is actually this. Okay, then we continue. Third, what do they want? They want total distance travel. Okay, jadi untuk kita kira total distance travel, you found that under VT graph, kalau kita kira gradient dia, kita dapat acceleration kan. Tapi kalau untuk kita kira displacement, kan, ini velocity ya, kalau kita kira displacement, untuk kita kira displacement, for example, for information displacement, what do we do? You just calculate area under the graph lah. You just find area under the graph. Okay. So kita kira dulu macam mana kita kira displacement. Find the area under the graph, which is area for the trapezium lah. Jadi udah senang, saya layan ini sebagai trapezium Jadi untuk kita kira area trapezium, macam mana kita kira? We use half darab dengan sisi trapezium. Sisi ini maksudnya length BC tambah lagi length AD ya. Ini maksudnya sisi. Okey. Jadi saya akan guna length ni berapa ni? 6 tambah lagi 12 6 tambah lagi 12 darab dengan height of the trapezium, which is 20 here. Which is 20 here. So we have this you pun kira inilah. Okay. So I think you get 180 Jadi ini displacement kan. Dalam soalan ini, adakah nilai displacement sama dengan distance? You found that sama lah. You found that. Wait, okay, later I will continue to explain to you about this. Okay, so this one is the first part of our question. So let us move on to the next video. Okay, thank you.